Hello students, I Vatsal Upadhyay welcome you on the Pass Thawanu Panchamrut program, which is jointly organized by the HB Kapadia Group of School and GSTV. So in the previous lecture, we understood about the MCQ portion, but today I have a next MCQ question that we have example. The depression in freezing point is 0.69 Kelvin when 2 gram phenol is dissolved in 100 gram benzene. If it is associated as dimeric, then its degree of association we have to find, and the molar depression constant for the solvent is given, which is 5.12, and another atomic mass of carbon, hydrogen and oxygen is also given. So by using this atomic mass, you can find the molar mass for the phenol. Now we have the four options. Option A 0.633, option B 0.743, option C 0.367 and option D 0.734. So to solve the MCQ, we have to use the formula. So what is the formula to find out this MCQs? What we have to find? Degree of association. So what is the degree of association formula? Degree of association formula is alpha is equal to I minus 1 n upon n minus 1. Clear? But as you see in this formula, we have to find the I, that means Van 't Hoff factor, and the n, which is a number of molecules. So to find out the I, we have to use the another formula. So we will use the formula for the depression in freezing point. Delta TF is equal to Kf into 1000 into W2 into I upon M2 into W1. What we have to find? I, that means Van 't Hoff factor. So as a subject as I, we will get another formula, delta TF into M2 and into W1 upon Kf 1000 and W2. Kf 1000 and W2. By putting the value of this, we will get a Van 't Hoff factor I. Now by using the Van 't Hoff factor I value 0.633 minus 1 n, then what is the meaning of n? Number of molecules we have given in the question. There is a dimeric. After dissolving the phenol in benzene, it's combined. That means it's a dimeric. That means it's a 2 upon 2 minus 1. So by this way, you can solve the alpha, degree of association. First of all, we have to understand what we have to find in the MCQ. Use this formula, and by putting this formula, see that what we don't have in this formula. Okay. Now in the MCQ section, there are some questions related with the organic chemistry. That means conversion product question, like if we have in the MCQ AgF plus NaI gives to A plus NaF. This kind of organic question can be asked in the board exam. So you have to find the A product. And what is the A product? You have to understand this is the Finkelstein reaction. This is the Finkelstein reaction. In the Finkelstein reaction, you have to exchange the halogen. Exchange the halogen. In AgF, there is a fluorine. In NaI, there is a iodine. Okay. Now, one product is given NaF. Then another product is NaF is given, another product is AgI. So by using this conversion, you can solve these MCQs of the organic chemistry. Now, in the biomolecules, there is a carbohydrates, which is very important topic. In the carbohydrate, glucose, fructose, short question can be asked, and we can say that mutarotation is important, and protein is very important. And another topic is coordination compound IUPAC name. So to solve the coordination compound IUPAC name, you have to know of some rules to solve the IUPAC name. Let's take an example of coordination compound like K4 FeCN6. This is the compound we have, which is given in the MCQ, and we have to choose the right answer. So first of all, there is a two metal Fe and potassium. So first we will write the potassium. Then ligand, which is the ligand? CN, cyanide is the ligand. There are 6 ligands. So hexa and cyanide is named in the coordination compound as a cyano. Hexacyano, and Fe, iron, is named as ferrate, So this is the name of this coordination compound. But this is not complete. We have to write the iron oxidation number. So how can we find the oxidation number of the Fe metal? Let's see. There is a potassium. There are 4 potassium. So 4K plus Cn, cyanide, has a negative charge, -1, 6 -1, and Fe, which we have to find the oxidation number as a X, is equal to 0. Total charge is 0, okay, on this compound. There is no charge on this compound, so we will put as a 0. Now after finding this X, we will get a +2. We will get +2. So this is the Fe oxidation number, and we will write as a Roman number. So this is the correct method to write the IUPAC name of the coordination compound. Another question which are asked in the board exam, like SN1, SN2 reactivity based question. So we will meet after the break, and after the break we will continue this topic. Welcome you after the break. In the last lecture we understood about the MCQ, and now we will continue our MCQ portion, which is the last topic of SN1 and SN2 reactivity based question. So SN1 and SN2 reactivity based question are very important, like increasing order of SN1 reaction, increasing order of SN2 reaction. Question are very important. So as you understand about the MCQ portion, our part A, which is a 50 marks question, is completed. Now let's see about the part B, which is also 50 marks, but part B is divided into 3 parts. Section A, short answer question. Section B, short answer question, and section C, long answer question. First of all, we will understood in part B 2 marker question. Total there are 12 questions. The good news is for this year is general option. You have to write only 8 questions. Each question carries 2 marks. So in the 2 marks, questions are like difference between Schottky and Frankel defect, which is given from the chapter number 1, and very important question. You have to write 4 points, at least minimum 4 points. Each point carries 0.5 marks. So by writing the 4 points, you will get a total 2 marks. Questions like organic conversion can be also asked in the board exam. Organic conversion we have is phenol to salicylic acid. So first of all, you have to write the phenol, and to convert the salicylic acid, you have to write the salicylic acid formula: benzene, OH, and COOH. So see, how can we convert the phenol to salicylic acid? First, we will add phenol into NaOH solution. So we will get sodium phenoxide, ONA, benzene, and ONA, sodium phenoxide ion. This is the phenoxide ion. In sodium phenoxide ion, we will add carbon dioxide gas in the presence of H plus, means acid. You can take any acid, HCl, H2SO4, HNO3. Then you will get a salicylic acid compound. So these are the questions can be asked in the 2 marks. Each step carry 1 mark. From phenol to sodium phenoxide, 1 step, 1 marks, and phenoxide to salicylic acid, 1 marks. So total 2 marks from the organic conversion. I am giving the tips for the organic conversion from the chapter 10 and chapter 13 are very important for the organic conversion. So in the 2 marks, this kind of question can be asked. Another point is naming reaction. Naming reaction are very important, like Hoffman reaction, Kolbe-Schmidt reaction, Aldol reaction, Wolff-Kishner reaction, Clemenson reaction, Hoffman-Bromobide reaction. These are the reaction can be asked because these all are the naming reaction. To learn the naming reaction, you have to complete the exercise of the chapter number 10, haloalkane and haloarine, and also complete the exercise of the chapter number 13, amine, which is very useful for the naming reaction. Now, if we talk about the another topics like any polymer preparation can be asked. Polymers like PHBV, nylon 6, Teflon, bakelite, melamine, nylon 6,6. These are the polymer preparation will be asked in the board exam in the 2 marker question. Now, another topic is chemistry in everyday life. This is the chapter number 16. Uses related question can be asked in the 2 marker question. Next, 2 marker question are very short question. Minimum you have to write the 4 to 5 lines to get a full marks. And questions like John refining method, lanthanide contraction, these are the question will be asked in the 2 marker section. Confirmation test related question like iodoform test, failing test, and tolerance test. These all tests are useful for to identify the aldehyde group. This is not useful for the ketone group. So these kind of question will be asked in the board exam. So learn properly to get a full marks in the 2 marker question. 2 marker question are total 12. You have to write only 8 questions. I have given you the some important point to cover up the 2 marker question. Dear students, you all understood about the 2 marks section B question. How can you score the good marks in the 2-marker question. But another topic which you have to complete and you have to learn, like SN1 and SN2 reactivity. It can be also asked in 2-marker question, like difference between the SN1 and SN2. And what is the meaning of SN1 and SN2? You all know, substitution nucleophilic reaction, first order reaction, and SN2 substitution nucleophilic reaction, second order reaction. You have to write the 4 points to complete this difference between the SN1 and SN2. And you have to keep in mind, for the SN1 is a 2-step reaction and SN2 is a 1-step reaction. So students, today we all understood this kind of question can be asked in the 2 marks, and in the next session after the break we will discuss about the 3 marks and 4 mark question. Dear students, after the break, now we will continue in the section B, 2 marks. We have another topic which is from chapter number 9, magnetic moments. From the magnetic moment, questions are like magnetic moment, you have to find the trivalent ion. So how can we find the trivalent ion magnetic moment? First of all, we have example of Fe+3, which is a trivalent ion. Atomic number of the Fe+3 ion is Zn is 26 and the electronic configuration is Ar 3d5 and 4s0. Why have I have written 4s0? Because that is Fe+3, atomic number is 26, but 3 electron is removed from s orbital. There are 2 electron is removed and 1 electron is removed from the d orbital. So to find out the magnetic moment, we will put the formula for the magnetic moment is mu is equal to root n plus 2. What is the meaning of n? N, that means number of unpaired electron. Unpaired electron, there are 5 unpaired electron in d orbital. So 5 plus 2, you will get 35. So root 35, the answer is 5.92. Bohr magneton. Bohr magneton is a unit of magnetic moment. So by this way you can solve the 2 mark question. 1 marks for the formula and 1 marks for the answer. Okay. Chapter number 9 is very important according to chapter weightage. So another point I want to teach you that the electronic configuration, and you have to understand the electronic configuration of 21 to 30 elements. These 10 elements are very important for the coordination compound chapter. Which are the 10 elements? Scandium, titanium, vanadium, chromium, iron, cobalt, nickel, copper and Zn. These 10 elements is completely used in the chapter number 9, coordination compound. And these all 10 elements configuration you have to learn. First, if we talk about the scandium, then what is the electronic configuration of scandium? Scandium number is 21. So we will write argon, Ar, means 18 elements, 18 electrons is completed. Then 4s2, 18 plus 2, 20 and 3d1. This is the electronic configuration of scandium. In this chapter coordination compound, you have to solve the hybridization. So to solve the hybridization, we have to know about the 21 to 30 elements electronic configuration. So To write the next element electronic configuration, titanium is 22 number. The electronic configuration is argon 18 and 4s2 20 and 3d 2. Which two elements is very important? There are two elements is very important in 21 to 30. Which one? One is chromium and one is copper. These two elements are exception. So in exception, the electronic configuration will be changed. Let's understand about the chromium and copper electronic configuration. So chromium and copper electronic configuration, chromium number is 24, argon, that means 18 electron completed, then 4s2 20 and 3d 4. But there is a change in chromium electronic configuration because it's exceptional element. So there will be a 4s1 and 3d 5. By this 5 electron, chromium will be stable. So whenever you find the compound with the chromium element, you have to know about the electronic configuration 4s1 3d 5. Like this, another element copper, which is very exception, 29 number, and electronic configuration is argon 18 and 4s2 20 and 3d 9. This is the general electronic configuration I have written. But why this is exception? Because the configuration will be changed 4s1 and 3d 10. 4s1 and 3d 10. So all the electrons are completed in d orbital. That's why a copper will be stable. So whenever you find the question with these two elements, make sure your electronic configuration as like this of chromium and copper. Now if we talk about the 3 marker question, in 3 marker question there are total 9 questions will be asked. There are total 9 questions will be asked. You have to write only 6 questions. Another general option. Each question carry 3 marks. So 6 into 3, total 80 marks question. And in the 3 marks, question like 1 or 2 numerical may be asked, like Nernst equation numerical. So what is the Nernst equation? If we talk about the Nernst equation, then E cell is equal to E naught cell minus 0.059 upon N log anode upon cathode. This is the equation of Nernst, and which is very important to solve 3 marker question. Okay students, so we will continue our 3 marker section in our next